Hello viewers, welcome back to my channel. This is John from Cloud Tech Insights. In today's session, we'll be learning how to use generative AI on Amazon Bedrock to query or analyze data on Amazon Data Lake. The tables are stored in Iceberg format, and we'll be showing how to write English, which converts into SQL, and SQL in turns query the Iceberg table for response. Let's dig in. So before we get into demo, I would just want to go over the architecture. So in this architecture, what we see is the endpoint, which is going through API gateway. API gateway is invoking an AWS Lambda. So you can either put a UI in front of API gateway and pass the prompt to AWS Lambda, and Lambda in turns connects to an Amazon Bedrock model, and then it prompts for a SQL query. It's basically prompting in English sentence or a prompt, and then it is asking the model to convert into a ANSI SQL, which is compatible for Athena. So once it converts the SQL, it returns back the SQL to Lambda, and Lambda then calls the Athena. The Athena uses the Boto3 API to connect to Athena, and Athena in turn calls the table or the Iceberg table or any Hoodie or Delta table on AWS Lake via Lake Formation or Glue Catalog. It connects through both and queries the table and brings back the results. So like I said, you can always add a UI and make it more of a chat friendly. I'm just giving you the core concepts. In this session, you will learn how to provide the metadata, the context to a LLM model in Bedrock, and then get the right response. The model decides what table to pick up based on the information that you provide in the data catalog metadata, and that is very important. In this demo, I'm just putting it as a string or a text within the code, but in the future you can hit the data catalog like Glue Catalog, Lake Formation, extract the metadata. You will have all the information on which table to look at, and then the prompt, when it converts it into English to SQL, it understands which table to pick up in the prompt. So in the session, I'll show you how the metadata is configured, how the Lambda is structured, and what models that we can use in Amazon Bedrock for English to SQL conversion. So let's check how this can work within AWS Lambda. So in order to explain the code, I'm using the SageMaker notebook. Doesn't matter what editor that you want to use, it's just for explanation, and then I can show you how that works in Amazon Lambda and Bedrock. So to begin with that, how we can configure the metadata, showing what are the tables available, what are the column, and what are the descriptions of each table, or what is the data that contains in each table. So this is very important. It's like explaining a model that, hey, these are the tables that we have, and these are the tables for users, these are the tables for sales. So when somebody asks you questions like users greater than certain age or certain cities, you should know which table to pick up. So basically we are giving the instruction, the prompt to the model so that it can figure out which table to pick up and what columns to query on. So here I'm just like hard coding the metadata. You can always hit the Glue Catalog or Lake Formation to get the table metadata from the data catalog, or else you can just use a hard coded one either in DynamoDB or simply keep it in S3 or just in the code so that it keeps it simple. But if you want to build a better production ready architecture, I would say you can directly hit the catalog and get the latest information from the Glue Catalog. This is the JSON metadata in a JSON format, and I'm just mentioning table here, the database here, and then I'm talking about different columns and what type are each column so that they know to cast columns when they return a SQL query from English. And also say what each column is for. I'm mentioning what the description of each column. That will help the LLM model to pick up the right column when it start converting the English to query. And also put the update frequency, usage. So this is, I would say, additional details. And similarly, I also put a sales table, Cloud Tech Insight, all these information here. And I just want to show you like what table it picks up. That is the reason why I added another table, so that it shows that it knows which table to pick up to get the right responses. Then we move on to the function that we write in Lambda. It has a couple of methods. The first one is to invoke the Bedrock model. Here we basically creating the Bedrock session, and we are configuring all the text. I'm providing in context information. So I'm calling these as a pre-context, post-context, and the prompt text. So the pre-context says all the information is provided in the JSON format, and I'm providing the JSON string so that it knows that you have to refer this catalog before making or converting the English to SQL. And then comes the post context. I'm just saying in the response, provide database dot table name and provide only the SQL, no other text. So I'm just saying, do not respond by giving additional information or the description of the SQL. Just give me the SQL back. So it's much easier to parse. We are prompting to get the right information, just the right information, so that we can use it to query the Athena table. And then comes the main prompt, where we are creating a SQL, saying that create a SQL to get users with age greater than 10. So now this is the main prompt, and I'm sandwiching the main prompt with the pre-context, which I mentioned right here, writing the metadata, the prompt string, and then comes the post context. So only the prompts underscore text will be provided by the user. In the interface chatbot, you can just say, give me the age greater than 10 for all the users. That's the only input that you need. Rest are all in context information. And then you sandwich it between the prompt style that the Claude V2 or Claude Instant prefers, which is the human, the friend, and assistant towards the end. And you can just print the prompt to see if the prompt is working. Now we are providing configurations, parameters. That's up to you, prompt and parameters that you want to provide. And once that is complete, we are invoking the Bedrock model, Claude V2. And like I said, you just need a small model. You don't need a big model to provide you an English to SQL. Again, based on your user requirements, you can get the bigger model, but most of the time start from the small model. So that's why we started something small, Claude V2. We provide all the information and then getting a response back here. And once you get the response back, the next one is to execute the SQL query on Athena. And this is where we are using the Bedrock 3 APIs to connect to Athena. We're providing the SQL string, which is obtained from the response from here, and then hit the Athena and start the query engine. And the next function or the method is the wait for Athena query results. So when you query Athena, you have to wait, give it a few seconds to respond. So this runs a check to ensure what state is the Athena query in, make sure that it's in the success phase or failed or cancel. Once the state is reached, it just responds and prints the results out. And then comes the main Lambda handler function. This is where the whole thing is coordinated. So basically it's invoking the Bedrock model right here, getting the SQL query, and then if it's a SQL query or not, and just say fail to translate. If it's a SQL query, go ahead and execute it in Athena. Once it executes in Athena, it just waits for the query, which is internally, if you look at the code, it just waits for the Athena query in the return statement right here. And once the query is completed or succeeded, it returns the results of those query. So this is at a high level. I have modularized it in such a way that each of the function can be tackled and tested in separate ways. And now what we do is we're going to apply the whole thing, copy and paste into AWS Lambda, and the Lambda can hit the Bedrock and respond back with the SQL query. So let's get started. So create a AWS Lambda function, open the code console, paste the code from the notebook, and I have put this code on my GitHub, and I'll provide the link in the description. So once the code is pasted, ensure that you have all the code part of the Lambda script, and ensure that you change the timeout from 3 seconds up to at least a couple of minutes so that it gives Athena the time to respond back. That's one critical thing, or else you will get a timeout issue in AWS Lambda. So all I'm doing here is, if you look at the main query, I'm just asking to create a SQL to get the users with age greater than 10. I'm not telling what table to use. I'm not telling what column to use. It should understand from the metadata that I provide, which is these two tables here. It will decide between which table to pick up for the query or the results. And we go ahead and save and then deploy the Lambda and then test it. So it takes 2 seconds for it to create the SQL, and the SQL goes to Athena. Athena takes again a couple of seconds to get the response back. So look at this. So we have executed the query successfully, and then we can see the response back here. So if you look at the response here, it's picking up the column name, the data from the iceberg table. You can see the Hannah 35, all this information is provided by Athena query, the response from Athena query. So this is how you can create a relation between Amazon Bedrock agents to AWS Data Lake. And this becomes more of an exploratory queries. People who are not into SQL coding can just simply write an English prompt, and then it converts into SQL, and then corresponding results are displayed. And this is a very simple example, and there are cases where you can also do table joins, and then in that situation you have to provide better metadata, so to show how each tables are linked, what are the columns to link, so that it can produce a query that can join a couple of tables and get the results that you want. Again, like I said, it's a simple example, something that easy to pick up, understand the concepts, and then you can build upon this information. So that's it from my side. If you like the video, please hit the like button and subscribe to my channel for the latest information.